Ladies and gentlemen, welcome back. My name is Aditya. I'm the founder and CEO of Skive and Robometrics Machine, and we are here live at AI Tech Talks. Today's topic is leading engineers. So, more specifically, what is the best way to manage an engineering team, or what motivates an engineer? So, we have three broad questions that we'll be covering today. And let's start with the number one, which is what inspires an engineer to do great work? Just as a background, I've been in the computer science industry for the last couple of decades. I started coding in fifth grade. I know a lot about how to make software. And most recently, in the last 10 to 15 years, how to lead a team, specifically an engineering team. Leading an engineering team tends to be a little bit different than leading, let's say, a marketing team. The things to consider that is just different. For example, there's a reason why a company like Facebook or Google have done so much better compared to some of the other companies in the domain or from that time. And that tends to be a little bit different than what Microsoft has done or how Oracle leads the team. So I will cover a little bit about that. Three words when it comes to inspiring an engineer: autonomy, mastery, and purpose. So when I say autonomy, it means you are giving an engineer enough room to explore and expand. Engineering, whether it's software engineering or it's hardware engineering, it could be even mechanical engineering. If you give the problem and you also provide the solution, exactly what needs to be done, it's much simpler. What fun is in only coding? So when you're talking about software engineering, for example, you could design a system yourself. You could come up with an algorithm for that, and then you can get somebody to code it. In my personal opinion, and a lot of engineers think about that, and I always consider myself as an engineer as well. The most fun is in the first half where you're trying different approaches, you're experimenting, you're designing the algorithm. And that also should and will take most of the time. The second part is when you're coding, and that usually is much simpler. And that's what we mean by autonomy. You need to give the engineer a problem to solve, but give them enough room to design the algorithm or to investigate how to solve the problem. With one caveat, you do need to have some guardrails. So if you give somebody, let's say, a junior engineer, and actually in that sense, even a senior engineer as well, that here's the problem, solve it. Especially if the engineer is not experienced or he or she has not been in an environment for a very long time, it will be hard for them to figure out where to go, where to look for, because the possible solutions are much the scope is much broader. That's why you need to at least set some of those guardrails. That's what I actually call that. That you need to say, okay, you need to get it done in X number of days. You also need to make sure that you use certain type of technologies, or you need to program in a certain way. For example, you need to use C, or you need to use Python, or you need to do it on an edge computing device. So you need to set some of the guardrails on what and how the solution should work. And that's important. The second is mastery. When I say mastery, it really means is that the engineer should be, as the time progresses, becoming a master in something. So he or she is building that expertise as he solves small problems, as he codes. And that's important because that experience in coding should really help to get to the next level. And that aspect becomes important where if you want to lead an engineering team, or if you want to lead an engineer, first of all, make sure you give them enough room. And more important, you give them enough room to grow as an engineer itself. And that's what I mean when I say mastery. So in a sense, you do need to show them that this is an important problem. These are a set of important problems to solve. And if you do that, you're building an expertise, and that expertise is well needed in that industry. Now, there could be a case where you are working in a startup, and sometimes you need to do multiple things to get the job done. But overall, engineer needs to know which field they're building the expertise on. What is the area? So it could be that they will be an experts in building embedded systems. They could be experts in working on healthcare. They could be experts on building AI systems for healthcare. Or even in the AI, they will be experts in really optimizing inference and deep learning. And that's what we mean by mastery. What I've seen is that when people graduate from school, whether it's a master's or even an undergrad, you don't have enough expertise. You don't really know how to work in a team, how to code in a commercial way. That's one aspect on the mastery side that you are actually learning. And the second aspect is that you usually will not be an expert in an area unless, for example, if you get a doctoral in an area like computer science or psychology or even philosophy or physics. The third aspect is purpose. It's a bit mundane to solve a problem just for the sake of it because your manager told you to do so. You need to lead the engineer by purpose. You need to tell them what is the bigger vision of the company, and more important, how does it connect to what you are doing. So if you're trying to solve a problem, I think that's great. But if you solve that problem where the performance increases by 2x, how will that performance gain help the company's product? And that's important, that you need to motivate by giving them a purpose. It's not just about programming, or it's not about having a line item in their resume that they work in XYZ, but it's really about having a purpose. And the combination of these three, autonomy, mastery, and purpose, is what engineers are looking at. And being myself, being an engineer, I could very well vouch for this. Our second question is the most important aspects of motivating scientific minds, and that relates to creativity specifically. How can you make a scientist creative? Or how, and it doesn't have to be in computer science, it could be in arts. It could be how to get an artist to draw something that's innovative. It could be for a photographer. It could be for a pottery designer. There are two aspects when it comes to motivating a scientific mind or to be creative. One is that person should know that area well. So if you are working on artificial intelligence, if you want to be creative in using artificial intelligence a certain way or optimizing artificial intelligence, you should at least know AI very well. So you need to be experts in that. And secondly, you need to be in the right environment. When I say in the right environment, it actually does mean physical environment. A lot of the time I've seen when I'm at the beach, walking on the beach, or just walking outside really early in the morning, that's when some of the best creative ideas come into my mind. So you need to figure out what is that best environment. It will probably not really help if you have your cell phone all your time and half the time you're watching a cell phone while in the meeting. That doesn't really induces creativity. And one of the things that you may have actually seen in the valley, that a lot of the time people walk and talk, where instead of actually sitting in front of a computer in a virtual conference or even a physical conference room, you will be walking in a park, or you will be walking on the backyard of your office and actually doing the talk. And that does induce that creativity aspect where you're not distracted, you are really focusing on a problem in a much more natural way. The third question is how to entice engineers to be creative and think out of the box. So first of all, remember that writing code is a creative endeavor. And if somebody is not creative in writing a code, he's probably not doing it the right way. And if you're getting away with writing a code where nobody cares if it's creative or not, then probably you need to change your job. It's not a job that will be interesting to you or will be useful to you, or you're not really learning from it. Coding itself could be simple. So you can write a piece of code, implement an algorithm, but now you need to figure out a more innovative way to care about, let's say I have limited power, or I need to execute this algorithm in 5 milliseconds instead of 100 milliseconds. You need to think. And that's the creativity aspect of it. Now, if you don't tell an engineer that you have these very set boundaries, or these are the KPIs you need to think about when writing the code, obviously they will do the simple way. And that's where the combination of autonomy, mastery, and purpose that I mentioned in the beginning actually comes into picture, where you want to give the engineer enough autonomy. You need to really get them to think deeper into a problem. And lastly, you need to tell them the overall vision where they have enough room to experiment and grow. Experimentation is important. I believe these days failure is overrated. It's not the failure that really counts, and you should not really focus on the failure. It's the learning and the processes that comes from failing. So you do an experiment, and if you're doing research or you're working on a really hard problem which needs out of the box answer, which may not be straightforward, you will fail, which is fine. But failing for the sake of failing is the wrong way to think about it. You need to experiment. You need to have very set processes to figure out whether that experiment succeeds or not. And you need to be lean enough so that if you're in the wrong path, you stop and you go back again. And you do that again and again. And sometimes you need to do some of these experiments in parallel because you have limited time. And I believe that is the secret to creativity, where you experiment, you are okay with failures, but the most important piece, you need to be systematic. You need to be process driven so that if the experiment is failing, you know right away, and you could go back and do the experiment again in a different way. Okay, folks, this is for today. Just a reminder, we are Robometrics Machine. We are indeed hiring. We build machines that feel. We have offices here in San Francisco and London, and please reach out to me personally or any of my team members if you'd like to talk to us. We are hiring both on the engineering side and on the non-engineering or non-technology side of things too. I will see you next week.